Hey guys, little Hamilton to start the day. We are on page 2 of our new packet. Again, please let us know if you need a copy of this. And we're going to go over a few things today, just to expand upon the start of trig. Now, when we talk about trigonometry, this is like a really super long word, right? Trigonometry. What we really mean is a comparison of sides and angles. And we're talking about right triangle trigonometry. So we're talking about comparison of angles and sides that are in right triangles. So let me just draw and have you guys draw. Oh, hold on, wait. I don't want to draw right here. I'll put it in here. Okay. So we're going to just name this triangle. It's a right triangle. Put my little marker in to show the right angle. Okay. Now, when we look at these triangles, what we talked about the other day is how do we identify what are opposite, adjacent, and hypotenuse sides. Well, first thing is you almost need to pretend like you're standing in one of these corners. So let's pretend that Alexander Hamilton, give him his snazzy hat, can you tell us him, is standing here. I always tell my kiddos to actually do this in this order: hypotenuse, opposite, adjacent. The adjacent is the hardest side to find. So let's start by finding the hypotenuse. You guys know how to find the hypotenuse. I start at the right angle and I go across. So this is my hypotenuse, right? Now, if Alexander Hamilton was standing here, where would we walk to go opposite? We'd have to go all the way across here to BE. That's going to be our opposite side. Now here's the trick, guys, and I think this is where students get confused. If you have the hypotenuse, you have the opposite, it means, guess what? Well, where's right next to where he's standing? That's the adjacent side, okay? So we're going to keep reviewing that again and again, but we're going to use the letter O for opposite, A for adjacent, and H for hypotenuse going ahead. Now, we are now going to look at one of the best and sneakiest tricks ever in the history of mathematics. It is called SOHCAHTOA. Okay? What is SOHCAHTOA? SOHCAHTOA is the sine of an angle is equal to the ratio of the opposite side over the hypotenuse. Now, that little theta, and again, I might be repeating some stuff. This is theta. It's a Greek letter, and it's a fancy word for any angle. So if you use this in like casual conversation with your math friends, like, oh, I was looking for theta the other day, everyone will think you're super cool. So just throw it in once in a while. Now, CA stands for cosine. Okay? And we usually abbreviate that COS of a theta angle equals, guess what? The adjacent side over the hypotenuse. Okay, we don't say cos. Even though it's COS, you say cosine. Okay, just some math terminology here. And then lastly, we have what's called the tangent. Okay, and we usually use tangent of theta. Notice I'm not saying tan, I'm saying tangent, even though it just says tan, equals the ratio of the opposite side over the adjacent side. So this is probably, I mean, I know I'm teaching it, so it's so obviously super important. I know you guys are focused. This is probably the most important thing to get down in the entire packet. Okay? And let me just show you guys one little trick. We're going to do it in a second. I like writing it this way. One of my students actually came up with this a few years ago. SOHCAHTOA. So one thing you might want to do is, even like if you're doing a couple problems on this, have this at the top of your paper so you know. Okay, so let's do a few examples here. Is this page? This says page 3 on the bottom. Oh no, guys, hold on. Page 3. Yeah, you know what, guys? This is really page 3. I'm sorry. That's okay. I still want it. This is the right page. We're doing the right page, my loves. Okay, So if we look here, we're going to write the trigonometric ratios. So remember, that's all that these are. Tangent is a ratio of opposite over adjacent. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. And again, that's sort of our trick here, SOHCAHTOA. So let's just look at this triangle here. I'm going to start by where I'm standing. So where is angle H? All these sine of H, cosine of H, tangent of H. Okay, so let's start. Our first step is always going to be labeling H, O, and A. So I'm going to start by labeling H. Here's my right angle. I'm going to go across. Oops, sorry guys. This is the hypotenuse. It's across on the right angle. And then, now we're standing at angle H. So I'm going to draw a picture of Miss Vala. I don't know if you guys know, but Miss Vala actually is a professional. Well, she's won medals in roller skating contests before. So she's going to be on roller skates. If she had to roller skate, hold on, let me give her some hair just so she looks more realistic. Clearly blue hair is the way to go. And Miss Val is always smiling, so I'll give her a smiley face. If she rollerblades to the opposite side, that would be the 4. And then the adjacent side is really what's left over, my loves, right? So the adjacent side is going to be here. So what's nice, my friends, is that we've labeled all of these. And if it helps, you can make a little checklist. H is the number 5, O is 4, and A is 3. So now we're going to use what we just learned, SOHCAHTOA. SOHCAHTOA. Okay, so now I'm going to think sine of H. The sine of H is opposite over hypotenuse. So instead of putting in O, we're going to put in 4. Instead of putting in H, we're going to put in 5. So that's it. That's our ratio. The sine of H is 4 over 5. Okay, let's try cosine. Again, I'm not saying cos, guys. We're saying cosine. Okay? Cosine is adjacent over hypotenuse. So cosine of H is 3 over, my H is 5. Okay, now tangent, my friends, is going to be O over A. Again, I'm getting that from our little trick of TOA. I'm looking for mine and work. I'm looking for mine and work. Looking for. Sorry, that was just like a perfect timing because you guys are working right now, right? So O over A. Okay, so now I want you guys to try. We're going to do this in sort of steps. So for example, 2. Okay, we'll make sure you guys have that one first. For example 2, my friends, now I want you to label H, O, and A. So go ahead and label those. Let's make sure you have them right. Oh, guys, notice, so we have angle E here. This is angle E. Sorry, mine got cut out. So again, maybe this is Mr. Fields. He's about to play a baseball game. All right, we'll put his little Sienna hat on, okay? Oops. I'll put a smiley face on him. Right, so if Mr. Fields hits a baseball across or opposite, that would be here. And that means our adjacent side is going to be the 4. So opposite is 3, and adjacent is going to be 4. Okay, so check your work, make sure you have those, and you agree with me. Now let's try to find our sine, cosine, and tangent. Okay, so sine is going to be O over H. So I'm going to put in sine of E equals 3 over 4. Cosine of E, so again, cosine is going to be ca, A over H. So our A is 4, our H is 5. Let me just change the color. And then tangent of E, remember tangent. Okay, so either go back to your little checklist up here or look on your picture. Tangent is going to be O over A, TOA. Our O is 3 and our A is 4. Okay, now we're going to talk more about this, but do you guys notice these are actually the same exact triangles? Compare and contrast this, my friends. Look at the sine of H. Do you notice how it's also the cosine of the other angle E? And then look at this, my friends. The cosine of angle H and the sine of angle E. Oh wait, hold on, did I do that wrong? Oh guys, hold on, I had a mistake here. This should be 5. The sine of E should be 3 over 5. Good thing I'm checking my work, just saying, Miss Vala, Mr. Fields. Okay, so I'm gonna stop there for today. And we're gonna keep doing more problems, but you guys are superstars. Keep up the good work. I hope you like the Hamilton, and we will talk to you soon. Bye guys.